Hello friends, let us discuss about the very important topic, that is triangles. In the triangles, the most important thing is the congruency of triangles. We should know about this. So when two triangles are congruent, okay, so how we are going to understand that the triangles are congruent? So the two triangles are congruent if and only if the sides and angles of the two triangles are same or equal. Okay, so let me read out this definition. Two triangles are congruent if the sides and angles of one triangle are equal to the corresponding sides and angles of the other triangle. To prove the congruency of the triangles, we have some set of rules. Among the set of rules, the first rule is Sas Congruence Rule. Okay, so let us see about this. What is Sas Congruence Rule? Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. That is SAS, that is side angle side, which means in the two triangles, two sides should be equal and also one angle which is corresponding should be equal. Then only we can say that this rule is satisfied. So here is the first question in the exercise 7.1, which is based on SAS rule. Okay, right, let me read out this question. In a quadrilateral ABCD, AC is equal to AD and AB bisects angle A. Show that triangle ABC is congruent to triangle ABD. What can you say about BC and BD? So this is the question. So this is the figure. Okay, so there is a quadrilateral, that is ABCD. Okay, so in that quadrilateral, this is a rough diagram. Okay, if you refer your textbook, you will understand the exact figure what it is. I'll show the question also, don't worry. So now coming to the solution. So first of all, what all things you will get in the given here? So there is a quadrilateral ABCD and AC is equal to AD. So can you see in this figure, AC is equal to AD. Those are the similar sides. Okay, right, those are the two similar sides of the triangle, and they have already mentioned that the two sides are equal. So the given thing has to be written first. So AC is equal to AD is the given thing. Right, next one is line segment is bisected. Okay, AB line segment bisects angle A. That is also clearly mentioned in the question. So we have to consider this one also, that is AB bisects angle A. Okay, right. Now what we need to prove is two triangles, that is triangle ABC and triangle ABD are congruent to each other. That we have to prove. So in order to prove that, we have to consider certain proofs here. First proof is whatever they have given, that is AC is equal to AD. So you got a common side here, common side in both the triangles. Second thing is what? AB is equal to AB. Okay, that is the arms, common arm of the triangle AB, that is common. So we have to consider that one also as equal. So you got two sides here. Okay, then you have one angle, that is angle CAB and angle DAB. They are equal. Why? Because angle A is bisected, and due to which you got two triangles in that quadrilateral, isn't it? Yes. So you have to take angle A as a common angle here. It is included in both the triangles. So you have to consider angle CAB is equal to angle DAB. Okay, so I have mentioned that the reason also, since AB is bisector of the angle A. Okay, so there is a bisection happened for the angle A, so it has considered as the common angle in both the triangles. Since you got two sides and one angle, henceforth you can say that SAS rule of congruency is proved here, isn't it? Yes, so you can write it as both the triangles are congruent to each other, and also you have to show that BC and BD. Okay, BC and BD, what about the sides which has been left? So there is one particular rule that is called CPCT. I am going to discuss in my next slide about that. So due to that particular rule, BC will be equal to BD. Okay. So when two triangles are congruent, you can say that the parts of the triangle which has been left, okay, that will also be equal according to the c.b.s.e rule. So due to which you can say that BC is equal to BD. This is our next question, that is ABCD is a quadrilateral in which AD is equal to BC and angle DAB is equal to CBA. Prove that. We have to prove three questions in that, that is both the triangle ABD and triangle BAC are congruent. Second question is BD is equal to AC, angle ABD is equal to angle BAC. Okay, look at the quadrilateral that is given here, that is ABCD, right? So let us start with the given thing here in the solution. What all is given? Given is angle DAB is equal to angle CBA, and also they have mentioned AD is equal to BC, side AD is equal to side BC, that they have already given. So what you got in given itself, you got one angle, that means two angles are equal here, and two corresponding sides here are equal, that is AD is equal to BC, angle DAB is equal to angle CBA. So you got one angle and one side. For Sas congruency, you need two sides and one angle, isn't it? So you need to get another side to prove the congruency. What is another side? AB, isn't it? In both the triangles, side AB is a common arm, right? So you can take AB is common to AB from both the triangles. So what you can say is AB is equal to BA or AB. Why? Because it's a common arm. So what you got? You got two sides, AB is equal to AB, AD is equal to BC, angle DAB is equal to angle CBA. So therefore Sas congruency is proved. What you can say that both the triangle are congruent, right? Yes, so congruency has been proved here. What is another question? BD is equal to AC. How we are going to prove that? So I have said you, there is a rule called c.b.s.e, right? So by c.b.s.e you can also say that BD is equal to AC. Okay. Then angle ABD is equal to angle BAC. That is also you have to prove. So how we are going to prove? Since both the triangles are congruent, so you can use the same thing, that is c.b.s.e as the rule to prove this, that both the angles are equal. Okay. So this is how we are going to prove the things in the given question. Okay. We have a rule called c.b.s.e, that is corresponding parts of congruent triangles. So this is considered when you prove that two triangles are congruent to each other. So this happens only in the congruent triangles, that in congruent triangles corresponding parts are always equal. Okay. So this particular rule we have to consider when you are proving the congruency of the triangles. Okay. Afc Congruence Rule. So let us look at this theorem. So this theorem states that two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. So that means if the two triangles have two angles and one side is similar, then they are said to be ASA congruent. Okay. Now this is the example where you can find the ASA congruency. Okay. So this is the question number 4th in exercise 7.1. The question is, L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC is congruent to triangle CDA. So you have a figure here. So look at this figure. So you can see that there is a formation of two triangles, right? That is triangle ABC and triangle CDA, or you can say ADC. Okay. So two triangles have been formed here, right? So they are asking you to prove the congruency of these two triangles. Okay, so in order to prove the congruency, what we have to do, first of all we have to consider the given things. What are given here? Two lines are parallel, that is P is parallel to Q and L is parallel to M. So this is what given here. Then, and also in triangle ABC and triangle C.D.E., what we have interior angles we need to consider, that is alternate interior angles. Which are those? Angle B.C.A is equal to angle D.A.C. Angle B.C.A is equal to angle D.A.C, and also angle B.A.C is equal to angle D.C.A. Okay. Why? Because they are alternate interior angles. So you got two angles as a common angles. Now, which is the one side that you need to consider here? That is the side AC. Okay. So this is common arm for both the triangles, isn't it? Common side. So therefore, you got two angles and one common side. Okay. So due to which ASA congruency rule has been satisfied. So you can say that ABC, triangle ABC and triangle CDA are congruent. Fifth, line L is the bisector of an angle A and B is any point on L. BP and BQ are perpendiculars from B to the arms of angle A. Show that question number 1. Triangle APB is congruent to triangle AQB. Second question. BP is equal to BQ or B is equidistant from the arms of angle A. So this is what the question I am going to solve. Okay, let us look at the solution now. So in the question they have given line L is a bisector of angle A and line segments BP and BQ are perpendicular. That was the given thing, right? So we have to prove the congruency of two triangles that has been formed due to bisection, isn't it? There are two triangles, triangle APB and triangle AQB. So let us look at the proofs now. So you can say that angle P is equal to angle Q. Why? Because both are right angles. And you got common arm in both the triangle, that is side AB. So you can take it as a common side. And third proof is that there is a formation of angle BAP which is equal to angle BAQ. Why? Because angle A is bisected, isn't it? Yes. So due to which you got two angles as common and one side as common. So what you can say that two triangles are congruent by the rule of ASA, rule of congruency. Okay. So you have to prove another thing here, that is BP is equal to BQ you have to prove. So that can be proven. Once the triangles are congruent, you can prove by the help of the rule of CPCT that BP is equal to BQ. Okay.